So today we are tasked with a question from Chris McMullen's multivariable calculus workbook, and that is, if A magnitude equals 6 and B magnitude equals 12, and then the angle between A and B is equivalent to 150, what is the dot product of these two vectors, and what is the cross product of these two vectors? So, if I can write B, okay. So to start off, what are the equations for the dot product and the cross product? So we know how to find the dot product, but if you're unsure, dot product is equivalent to the vector A times the vector B equals the magnitude of A times the magnitude of B multiplied by cosine theta. And for the cross product, it is about the same formula, except you multiply it by sine of theta. So now we have these two equations, we can begin solving the problem. So to find the dot product of A times B, we know that magnitude of A is 6, and we know that magnitude of B is 12, and we know that the degree between the two is 150. So we have the equation set up, so reducing this is 72. And for the cosine part is the easiest if you set it to, unless you already know all of your degrees in cosine, but I would prefer to set it to a radians form, which if you're unsure, you just multiply the degree, so 150 degrees times pi over 180, which will become 150 pi over 180, which simplifying it is 15 pi over 8, which then equals 5 pi over 6. Okay, so we know that this is cosine of 5 pi over 6. Now, we just have to figure out what cosine 5 pi over 6 is, which if you forgot your trig unit circle stuff, there's a little chart that I was taught, which is to set up pi over 6, pi over 4, pi over 3, and then set up cosine or sine and then cosine and then tangent down here. I think it's easier to remember it this way because sine divided by cosine equals tangent. But let's get rid of the tangent for now, and then you just go 1, 2, 3, 3, 2, 1, put all of them over 2, and then take the square root of each one of these. And there's no square root over 1 because the square root of 1 is, of course, 1. So then 5 pi over 6, here's pi over 6, and cosine is equivalent to 3 over 2. Now you have this, and the part that you need to make sure you remember is it negative or is it positive? And to do that, let's set up a makeshift unit circle. Quadrant 1 is plus plus, quadrant 2 is minus plus, quadrant 3 is minus minus, and quadrant 4 is plus minus. So where does 5 pi over 6 fit into this unit circle? Well, if this is pi and this is 0, it's going to be in quadrant 2, so this would make it a negative square root of 3 over 2. So back into the equation, we have 72 times the negative square root of 3 over 2, which is equivalent to 72 over 2 square root of 3, which equals negative 36 square root of 3. So we know that this is equal to negative 36 square root of 3. And for the cross product, we're going to do the exact same thing, except for cosine, we just substitute sine in. So let's do that now. So a cross product between A and B is equal to 6 times 12 times sine of 150. So this is 72. And sine of 150, again, is going to be the same as sine 5 pi over 6. And let's set that graph up one more time. Pi over 6, pi over 4, pi over 3. Sine divided by cosine equals tangent. 1, 2, 3. Okay. And square root of each of these. 5 pi over 6 is going to be 1/2. And where is 1/2 in the unit circle? So again, we're going to be in this quadrant. We have plus, plus, minus, plus. Sine is the y value. So we know that this is going to be 72 times 1/2. And this is equal to 36. So these are just two problems from Chris McMullen's multivariable calculus workbook. I'll have it in the description, and I highly recommend checking it out if you want more practice problems.